So we were doing this bottom-up approach. So we were trying to find out, in the previous case, we were trying to identify the student.
Yeah.
So we are trying to identify one of the categories on the card. Basically, the card has the name, so we are trying to identify the name based on some other things.
It's a kind of classification system.
Yeah, so kind of classification. Yeah. So is it the student or not?
Yeah,
That's what
yeah.
we are trying to say. So, but we could also apply it. We were using that time the marks to determine this. But maybe a more relevant thing which people, the students or the teachers might be interested in is predicting the marks. Right?
Predicting the marks.
So maybe you want to look at the marks in sub-subjects and figure out what is this.
We tried that earlier. We saw that we couldn't predict physics from maths.
Yeah, we couldn't predict physics and math. But maybe supposing you take 2 of the subjects.
Oh, and predict what?
Say, can I estimate what the total will be? Because the 2 subjects will add up to part of the total.
Want to take chemistry this time?
Okay, let's take maths and chemistry maybe.
Okay, maths and chemistry. And then from maths and chemistry,
So maths and chemistry, maths is out of 100 marks. Chemistry is also out of 100 marks. So if I add up, I get total out of 200 marks.
So multiply 1.
But I want to know the total out of 300. So I can predict that it's, to start with, I can predict that it will be 1.5 times 100.
You take the sum.
To add these things and take the sum.
I won't give you the marks. I mean, giving the marks is too much. I'll give you
Yeah,
only
so
the
maybe you can give just
nearest, round off to nearest 10.
Okay, round off to nearest 10.
Yes.
Okay. So
let's say maths in this case, for example, we take Tausif. Maths 90.
Okay.
And chemistry 40.
Okay. So we'll take 90 and 40. So this is what I will say. So Mr. Tausif. So here is 90. Here it's 40. So this total is 130.
And you will multiply 1.5.
Then I will multiply by 1.5.
But this, I mean, this rule is, you started with this rule. We hopefully will change it. You may not need to change, we'll see.
We'll see. But 1.195 is quite far away from 216, right?
It's a bit far away.
Yeah.
It's 216, 190, so that is underestimating.
Underestimating.
So what do I change? Do I change 1.5 or?
So obviously, so one
Or
possibility
do I change
is,
I don't add.
Yeah. So this is like saying I'm taking 1.5 times this. So I'm giving equal weightage to
maths
and chemistry. But maths is a higher mark. So this is maybe getting lower because maths actually is more reflective of the total for this student than chemistry is.
Yeah.
So therefore the total is high compared to the maths marks, but the chemistry is giving you a low prediction.
So we could,
yeah, so we could adjust this 1.5 also, saying maybe maths is more and okay.
So take 1.6.
Okay, so let's scale this. So maybe I make this
0.1 you add, which 0.1 of 90 is 9. So 195 plus 9 is 204.
But I should reduce from chemistry also. No? I mean, I can't give all, because then you will get, everything will be very high.
That is true.
So maybe these two together should add up to 3. I mean.
Okay. You're dividing 3 points, huh?
Yeah.
Among, huh?
Yeah.
300 basically you're dividing.
Yeah, 300. So
300, 160 goes there, 140 comes here, something like that.
Yeah.
You don't have the physics mark.
I don't have the physics mark, so I'm trying to.
It happened this year because of Corona. They did all that.
Yeah.
Right? They figured out the one subject marks with another subject marks.
Yeah.
Some algorithm they used.
Yeah.
So they are trying that similar algorithm.
Huh. So if I do this, for instance, what did we say? We get here we will get 56, right? 1.4 times this. Right, so 4. Yeah. So I think we get 56 instead of 60, which is what we got 1.5. But then here we will get an extra, so we get 99. Oh, sorry, we get 130 plus 9, 139. No, sorry. Is that right? So 90 into 1.5 is 135.
9 ones 9 plus 13.
Plus 9. So 144 we will get.
Correct, 144.
Right? So now in fact my estimate goes up a little to 200.
Still not good enough. 216
Still not good enough. So we could reduce it a little more.
Okay, make this 1.3 and 1.7.
So let's say 1.7 and 1.3.
Okay.
So essentially
9 763, 9 ones 9 plus 6, 15, 153.
So we'll get 153 and 52. The 52?
13 4 52, correct.
So now I've got 205.
I think
So I'm inching there. But this is all based on one thing.
card, no? You shouldn't
So
do it.
now we look at the next, some random other sample. Maybe just dig down and pull out some other card. You can see whether this makes sense or not.
Okay. I have taken Samir.
So Samir.
The algorithm is 1.7 times maths
Yeah.
plus 1.3
Yeah,
times
so
chemistry.
first we have to round off. So we take his maths as 80
80.
and say chemistry as 90.
Yeah.
Right?
Yeah.
So it takes 1.7 times that. So that is 80 and then 56, right? So 136.
136. Okay.
And 1.3 times that is 90 plus 27.
117.
117.
Not bad.
253.
Can you say that?
So
It's a better estimate for Samir than for Tausif
Yeah.
actually.
So we
Okay. Let's take one more.
let's take one more and see if we have stumbled upon a very good relationship. Aditya.
Yeah.
So again we round off. So mathematics comes to 80.
80.
Chemistry goes
Also
to
80.
80.
Yeah.
So 1.7 again we have 136. And here you have 104.
Yeah. 240.
240. Less,
It's all right.
but not
Okay.
too bad.
Not too bad. Plus minus 10, I think it's okay, somewhere around that. Let's try this guy. Harish.
Okay. So here there's a big variation in the marks, so there might be some variation in our outcome also, because the
But
maths
you know,
is,
so far, this guy we underestimated.
yeah,
This guy, 253,
was overestimated, right? So maybe I should write that. So the actual thing here was
Marginally overestimated.
215. The actual thing here is 250,
yeah.
and the actual thing here was. Do you remember?
Aditya.
Aditya's 250. No. Aditya's 252.
Yeah.
Okay. So here we were quite off. Okay. So Harish, now let's see. So 60.
So we underestimated this guy and this guy, but slight overestimate here. So actually we are still erring on the
low side only.
lower side only.
Yeah.
Okay.
So let's see what we have get with Harish. So 6. So 6 sevens are 42. So we should get 102 here. Right. And here we get 117. So this tells us which he should have got 219. Which
Overestimate.
is a fairly big overestimate compared to 198.
So we should, because he's got high in chemistry,
Yeah, so
should lower the
chemistry.
weight for chemistry even more.
Yeah, but
It looks like
looks
1.2 and 1.8 may be better actually.
yeah. So then we'll have to go back and calculate all of these guys again.
Shall we do that? I mean, just to
Okay,
heck,
so
just for the heck of it. Let's just do it.
Just to 1.2 and 1.8. Right. So we have 90 plus 81, right?
9872, 919.
Sorry, 162, right? Sorry, 162,
and 48.
48. So we'll come to 210. So now we are
Closer, much closer.
closer, right?
Much closer, the 215.
So here we have now 64, so 144 and 108.
108, yeah.
So we have 252.
Very close.
So slightly gone down,
Yeah.
but closer to that.
Closer, yeah.
Here it's not going to change because we have 80, 80.
80.
But anyway, so we can say 144 plus
96.
96, and it's going to be the same, I guess.
So it didn't change it. So it didn't make it better.
because the two marks are the same,
Yeah,
right?
exactly.
So it doesn't
Yeah,
matter how
doesn't
we
matter.
combine them. And here it's going to hopefully change. So 60 into 1.8 now. So this now becomes 108. And 90 into this thing will become
108 again.
108 again.
216.
So we
Slightly
slightly
came down,
reduced.
but didn't make it much better. Okay, let's try one more. Rida.
Oh, very low in maths and quite high in chemistry. So now which will go with the most recent one, 1.8.
Yeah, why
Okay.
don't we do that? Yeah.
So that's 72 here, I think. Right, and here it is 96. Right?
168. Not bad. Huh?
Yeah,
Huh?
surprising.
Not at all bad. Okay.
So,
I'm inclined to try one more. Let's see. Srinidhi. So this algorithm works, huh? Take 1.2 times maths and 1.8 times maths and 1.2 times chemistry and add it up.
you get something close to the actual total.
Okay.
So it's 50, but after doing some rounding to start with, so we'll ignore some Okay, so 50 into 1.8, so that's 90. 70 into 1.2 is 84.
174.
Get 174,
Underestimate.
which is a
So far we are only underestimating. So if at all,
yeah. So in rare cases, like in Harish's case, because the chemistry mark was a very high mark compared to the total,
in that case we overestimated.
But in most cases we are getting an underestimate.
So we should even do 1.8 should even go even higher. Something like that. Huh?
Maybe.
Okay, let's try Geeta. So here is another kind of algorithm, right? We are building bottom up. What are we doing here?
So here we are trying to fit these
Doing a fit
these coefficients, right?
with
So,
these coefficients.
yeah. So we have multiplying something. So you know this linear thing, right? Ax plus by.
Ax plus by.
So we are trying what is a good value of a, what is a good value of b.
So that Ax plus by line will go
near the total. That we want. Yeah.
Huh?
So
Something
we are
like
trying
that.
to find
So totals are all plotted somewhere. Two-dimensional diagram.
Yeah.
Right? X and y. Totals are plotted on this diagram.
Yeah.
You should try and draw it. Draw it for these points. See what it looks like.
Yeah.
90-90.
So 90-90 is going to be, I guess.
Oh, this is going to be out of range.
Yeah. Because I'm going to get now.
Doesn't matter what it is.
Yeah. But it's going to go to 270, I think, ultimately. Because
180 to 1.5, 270, yeah.
So I'm going to get
It's overestimated.
and that's
Okay. See, so what are we doing? We are doing, so X is basically the chemistry mark, let us say, Y is the maths mark.
yeah.
It's a 10 by 10 grid, something like that.
Yeah. So
Not
we
even
actually
do
it's,
some-
yeah, it's like a, so it's more like a three-dimensional picture, I guess. No, so we have to draw it carefully. So we have like,
Oh, okay.
right, so we take chemistry here, and you take say maths there, and then at every point if you pick a combination of maths and chemistry here, then at this point you have some total.
Okay.
Right. So this is what we are trying to estimate. So this is some A times maths plus B times chemistry. Right. And so our current estimate is that we should use 1.8 for M A and 1.2 for C. And at each point we have an actual total, so we can take the actual total and compare it to that and kind of estimate whether we have got a good number or not. So initially we gave equal. We said take 1.5 maths, 1.5 chemistry, and that was actually not doing so well. If you go back to 1.5 here, for instance, right, then you will get one. Actually, you may get a better thing here. Here you get 180.
If you do 1.5, 50 plus 70 is 120 into 1.5, 180.
So you get a better estimate than that.
So 1.5 would have been better.
Yeah. Whereas here, for instance, if you take the same, again it's 120 into 1.5, you will go overshoot, right? So instead of 173, you will
So
go
this
higher.
1.6, 1.4 may have been better.
Yeah.
So what might be a way to do basically is that for your sample set itself, you will take various weight combinations, W1, W2.
Yeah, and then for each of them, you will check for that particular sample, and then you would take maybe, because yeah, so we saw some will overshoot, some will undershoot.
But actually what you should do is some distance calculation.
Yeah, because as long as you're close, you don't care whether you're +2 or -2. They are equally bad or good compared to +10 and -10 or uniformly +10.
So you should take the difference and square it.
We could do that, so that make it a positive number, right? Yeah, you can square that difference, right?
Also square somehow the distance, x square plus y square, square root of is distance.
Yeah.
No?
Yeah.
So you take the difference.
Yeah. So here you would say
10 is the
10
difference.
is difference, so 10 square, or here is 3 or 2, whichever one. So the last thing we got is 5 actually. So 5 with 1.8, 1.2, the distance is 5 square, 25. Here the distance is 2 square, 4. Here it is 8 square, and so on. So we will keep doing
Square of
this,
the distances.
and then we will add it up, right?
And add it up and see which of these combinations gives
So
you
that
the
for
least
each combination we will get some, in some sense, the sum of the errors, right? Squared errors, sum of the squared errors. So you square the difference each time, add it up, so you get the sum of the squared errors, and you want to find that combination for which that sum is
the least.
The least. So actually we have been of course picking numbers which are like 1 point, there's nothing to stop us from doing 1.75.
1.75.
And also we have arbitrarily decided that they should add up to 3.
Right, yeah.
It could be that
It need not be
it
3.
need not be 3 also. It could be something else. So there is a more complex search for these things that he has to do.
But if you do that, let us say, maybe some math method is there of doing it. If you do that, then you will get some coefficients W1 and W2 at the end of it.
Correct. Yeah.
Based on samples again.
Yes. Yes.
And based on that you create this function
Yeah, so you get this
AM plus BC.
Yeah, correct.
And it kind of predicts the total. Some error is there, but the error is kept as minimum as possible.
Right. Yeah.
And hopefully that after some number of samples are seen, you can apply it now for any other card and start predicting the total.
Yeah.
You won't get it exact, but more or less approximately you can get it.
Correct.
Right?
So as you said, like in this board exam situation, right, if somebody misses one exam and you want to fill it in, then if you know the score in 2 exams that they have taken, then you can make some, based on this pattern, you can say, okay, I will give you this
award this
total to you, and therefore this is implicitly this is the physics marks that you should have got.
Yeah.
Now of course if that student happened to be bad in physics, that would be good for them because they would get a higher score. If they were very good in physics and their physics marks was boosting the total, then it will be a disadvantage. But for most people, hopefully this will be correct because this is the best fit. So that's one way you can use this.
Right. So both these methods, what we saw, basically making the tree, decision tree, to categorize or classify or whatever it is, the item, as well as this, which is prediction.
So numerical prediction
type stuff here. But you need only numbers, right? Numerical prediction can only predict on numbers.
Yeah. So it would not make any sense.
Gender.
We can't put we can't say 1.5 times male. Right? This doesn't make any sense. So this would not make any sense. Or 2.5 times
numbers. Or you have to convert a m into a number.
Yeah.
Meaningless it will be.
It won't make sense. Yeah.
Unless I know the average for males, then I can use it.
Yeah.
Huh?
Yeah. So
you can the average for males.
Yeah. So you can actually do some splitting. You can say for males you have one equation, for females you have another.
Males have an average, females have an average. Oh, okay. I can make 2 equations.
Yeah. You can find a different A and B for male and different A and B for female. That also you can.
That you can do.
So you
can do part of this and part of that.
Yeah.
Partly tree.
Yeah.
First you do tree. First you do MF.
Yeah. So you group them into 2 groups, and in each group you find.
You have one A and B over here, one A and B.
Yeah, but because perhaps the performance is different based on that. Now it may be that the correct grouping is gender. It may be the correct grouping is city. It could be.
Yeah, Chennai might have scored very high.
Yeah. So you don't know. So but by grouping you might get for that group you might get a better estimate than for the thing as a whole.
So in all these things, whether it is this, that, or a combination, now we are seeing a combination also.
Yeah.
What you do basically is a slightly different method from what we have done earlier. You take a bunch of sample cards.
Yeah. And then from that you try to build this
to build it up.
Yeah, your code in some sense. See, this is also, in some sense, this is a procedure.
Coming out with a procedure.
This is a procedure. Your procedure
but you
is.
didn't write the procedure.
Yeah, procedure is take 2 parameters M and C and return back AM plus BC, where A and M I don't know in advance.
A and
right?
B
When I wrote the procedure, I didn't know the A and B, but I found them out by looking at a bunch of samples. So that is a crucial thing.
And in the other case also we said that if there are 2 procedures, which is one in which you start with grades, and then after that you do gender, another one we start with town and then do something, something else you do something else. Then you basically try all these 3 different procedures.
Yeah.
Try this, and see which works out better.
So because there if you look at the procedure, it's basically saying something like, I mean, we have, in a way what we are doing is we are fixing a skeleton, right? So we are saying if, and then we have some condition to be asked, and then we have else. Okay, so we know that our first question comes here, but we don't know what question to ask here. So we try grade, and then we say, if we say grade, will the procedure work better? If we say city, will it work better? If we say gender, will it work better? And so on. And then within this again there is going to be some, once we have decided on that, then again inside there is going to be another second question.
Or it could be a numerical equation like this.
Yeah, right? Or it could be an equation. So we could now do that also.
And so okay.
Yeah, so here the other option is here instead we could say find A, B for.
Oh, okay.
And here we find a different
pair.
Yeah, maybe some CD. So we'll get CM plus. And these two may not be the same. because at this top level when we have
there
group,
we saw actually when we are going down the tree, the different question could be asked depending
Yeah.
on which branch you take.
Correct.
Right.
Yeah.
In one case you could ask gender, another case you could ask
correct,
town.
yeah. So here for
Also you
example,
can
if
do-
we were in this case, then we would have, if we had another if here, right, then this question could be some, so this could be something else, this could be city, and this could turn out to be whatever month. It's possible.
So unlike a normal algorithm, we are actually this criterion, what criterion to check itself
Yeah.
is emerging from
Yeah,
the
it's emerging.
data
Yeah. So what we are fixing is kind of the
skeleton.
the structure of what the program is supposed to look like, what type of decisions it's tried to make, but what are the actual checks that it makes for those decisions, we are not trying to
Fix.
Yeah, we don't know. And the same thing might be different even if we change to a different class or a different group, different school. So this pattern that we derive for one group is not,
Might work in
it's-
another
it's-
class.
It may not work in another class. We
May
might
not
know
work.
in general that there is a relationship between
But this that method, this skeleton can be carried there and
Yeah.
applied to the data
Correct.
there.
yes.
Right?
And even in the same class, I mean the same school, it might vary year to year, right? So over a period of time, so if we apply it this year, we might get some number. Next year, if we apply it to the class, we might get a different number. So that also.
So you are expecting that what you should do first is you take for any given situation you want to do this method. You take some samples from that.
Yeah. So you must make sure that the
Don't
samples.
take samples from somewhere else
yeah,
and try
yeah,
to apply
yeah.
it
The
here.
samples must be
From that.
From the. They should represent the type of.
Represent that kind of.
Otherwise, you are not going to make any sensible prediction, right? So you
You
can't
take samples from there,
Yeah.
but skeleton is there. Then use that skeleton basically to populate.
Correct.
Once you have got that, then you use that to do whatever you want to do, classification, prediction, whatever you want.